Hello, everyone. In this lecture, I will cover the last chapter of the textbook, which deals with managing project control and closure. Our learning objectives for this chapter is to understand the importance of and apply techniques associated with project control and project closure. To appreciate the importance of project control, let's examine the case study that was presented in the textbook about computerized baggage handling system that was implemented in Denver International Airport in 1989. Initially, this system was intended for the use by United Airlines only. Later on, however, the scope changed to implement the system airport-wide. This change, of course, impacted individual airlines and their plans. And because of lack of control and good communication and coordination, the system ended up being implemented with a 16-month delay and a $2 billion overrun. There is a range of philosophies in effectively controlling projects. On one end of the spectrum, it is the dogmatic approach where no change is accepted. This approach may be appropriate for large projects that are well defined. On the other end of the spectrum is the so-called laid-back approach, where change is welcomed. This approach is appropriate for smaller projects, or in agile approach where projects are approached in even large projects are approached in small chunks. So in that case, in the case of agile, as we have discussed, change is also welcome. The more pragmatic approach is somewhere in between the two ends of the spectrum. And basically, in this approach, changes are assessed and implemented if the impact is not huge. As a project manager, we have a number of levers that we can use in controlling changes. Communication is particularly important lever to make sure that all project participants report changes and all project participants are aware of all the changes that impact their work. As we're dealing with change, it is critical to get team members involved in assessing impacts and identifying ways to minimize the impact of change. Each change will require analysis and a decision how to address it. The analysis should be done as quickly and thoroughly as possible, because the longer we take to analyze, the more costly and the more difficult the change will be to implement. Another important factor in controlling changes is to get the commitment from all stakeholders to try to maintain the schedule and follow project processes and not introduce changes without thoroughly analyzing it. So we just discussed the importance of communication in controlling changes, but these are some of the obstacles in communicating problems or bad news. Project members may be hesitant to communicate problems up the chain or blowing the whistle because it may involve some personal risk for the person who reports it in terms of how they are viewed by other team members. Furthermore, sometimes the management ignores whistleblowers' warnings, and so they would not help the situation. Because of these issues, in many cases, people withhold bad news about problems and they do not report those issues as they occur on projects. There are several techniques for managing project control. We need to document what is happening on the project in terms of meetings or outcomes, the progress reports we issue, etc. We also need to continually monitor and control work by performing integrated change control, which we'll discuss in a minute. We also need to monitor and control various aspects of the projects, such as scope, schedule, costs, etc. It is very important to monitor the communication and engagement with key stakeholders to ensure that they are on board with the changes we are incorporating in the project. This is a uh, sample project log capturing major project events such as project approval, formations, or critical meetings. This is a template for reporting project progress. As you can see, some of the key items to be included are the list of what is completed and what is not, activities scheduled for the next period, issues that have been encountered or resolved, and any changes to schedule or cost. When a change is identified in a project, we need to follow integrated change control process. This means that the impact of the change needs to be analyzed and a decision has to be made in terms of either accepting the change, rejecting it, or deferring it. This is an example of the process flow for change control system, which is basically the process for changing the scope of the project or a product. Usually there is a project change control board that ultimately decides if the change should be implemented and approved and implemented or not. We use the change request log to keep track of all the changes and the decisions that were made about those changes. Through our integrated change control, we manage changes to various aspects of the project. This slide shows the processes associated with scope changes. One of the techniques is variance analysis. The variance analysis is used to identify any variation from original plans. One of these methods is earned value management technique. Other methods for variance analysis is by examining quality deviation or schedule variance. Of course, every time that a change in scope is approved, then we need to examine the impact on work breakdown structure and modify WBS if required. For schedule variance, we can use a number of techniques such as earned value, or in the case of agile projects, the burn down chart. As tasks are completed, we can compare their actual duration versus estimated durations and calculate the schedule variance for each task. As changes are accepted, the impact on the schedule need to be shown in the project schedule. In some cases, changes may actually change the critical path of the project. So we need to be aware of that and identify new critical paths as changes are implemented. As part of our schedule monitoring, we need to look and look at the completed tasks as well as those that are perhaps postponed to the next period reporting. Similar to schedule control, we have techniques to control costs, such as earned value and variance analysis. As you know, the actual cost of activities, you can compare those with your planned cost for those activities. So you can compare the forecasted costs against the budget. We can roll up individual activity costs to see the project's overall cost performance versus the budget, as is shown in this graph. As part of the project cost reporting, we need to report cost variances over budget, as shown in this example report. So we have talked now a couple times or mentioned a couple times about earned value management. So let's look at this method, which is a technique assessing variances and forecasting final project cost and schedule. There are many terms in the earned value method. Planned value is essentially the project budget. Earned value is the portion of the budget that was for the work that is performed up to date. Actual cost is the cost actually incurred for the work that is accomplished to date. Here are some more terms used in EVM. For example, cost variance is the difference between earned value and actual cost, while schedule variance is the difference between earned value and planned value, and so on. This chart shows the key EVM terms graphically. For example, you see that cost variance is the difference between earned value and actual cost. To understand EVM, let's look at a simple example project that is supposed to take 2 years and it's supposed to cost $2 million. Furthermore, the cost is forecasted to be spent uniformly throughout the project. This means that the cost for tasks in each month is forecasted to be the same as other months. So it's a very straightforward project, or a very simple project. After 6 months, we calculate that $375,000 worth of project work is completed. For that work, however, we have paid, our actual cost for that work has been $625,000. The question is, what would the cost and schedule forecast be for the project when it's completed? To answer that question, we first calculate the cost variance, which is 625,000 minus 375,000, so it's $250,000. Then we calculate the schedule variance, which is $125,000. Assuming that productivity stays the same for the rest of the project, by extrapolating, we can find out that it will take 32 months to put in place the $2 million worth of work that we need to put in place for this project. That is an 8-month schedule delay. Similarly, if we extrapolate from the actual cost information that we have, we will find out that the expenditure in 32 months that the project will last will be about $3.3 million, which would be $1.3 million overrun. So this is how we use earned value management method for forecasting the outcomes of the project based on what we know about the project as we are executing it. Moving on to quality, this chart shows the inputs and outputs of the control quality process. For example, to ensure that the system is capable of certain number of users, we need the system to go through load testing. If the system does not pass the required performance targets, the performance issues need to be addressed, and the system needs to be load tested again until it meets the requirement. At that time, we of course document all the test results in our test reports. Quality management plan is one of the inputs to the quality control process. For example, the plan establishes the quality standards that the system has to meet. So those are the standards we ensure throughout the project as part of our quality control that the system is meeting those standards. Quality checklists are one of the inputs and tools for quality control, as is shown in this slide. We have discussed several other quality control tools in Chapter 8. The Ishikawa fishbone diagram is for identifying root causes of quality issue. Control charts are used to ensure that the system performance is within the limits established by requirements. And Pareto chart or Pareto diagram helps us to focus on the most important issues that need to be addressed to improve the quality. We also need to monitor the risks throughout the execution phase, as we have discussed in the past. One of the key inputs to this process is the risk register, where we have recorded all the risks that we have identified and the action plan that we have laid out to address those. All risks need to be monitored as project progresses, as some of these risks that we had identified earlier may disappear, and some new risks may surface as we are executing the project. So we are continually have to monitor our risk register to make sure that it is up to date. In terms of controlling procurement, We can audit procurement process to ensure all elements of the procurement process are carried out properly. We can conduct performance reviews to ensure that the contractor is fulfilling its obligations. We need to ensure that any claims are addressed quickly so that they don't result in bigger disputes. And finally, we need to ensure contracts are properly closed after we had ensured that their obligations are met. In Agile, burn down chart is an important control tool. The burn down chart not only measures the team's progress, but also establishes a velocity for the team, which helps us in forecasting the timeline for finishing the project. There are some key execution and control activities in Agile. For example, pairing programmers, putting programmers together, two programmers together, is a good practice to improve the quality of coding. Also, reviews and retrospectives after each sprint will identify issues that need to be addressed in the subsequent sprints. The last phase of the project is closure. As part of closure, training and support will need to be handed over from the project team to the support staff. It is important to ensure all project records are complete and lessons learned are captured in a way that would be beneficial and useful to future projects. So to properly close a project, we need to ensure that the end of the project report is complete. User support and maintenance are handed over to the support staff, and post-implementation reviews are also helpful to ensure lessons learned are captured. This is a sample table of content for an end of project report, which will document how the project achieved its objectives, or if it didn't, why not, as well as documentation of changes that occurred during the project. This concludes my lecture for chapter 12, as well as all my lectures for HAP 460. Thank you very much for your attention, and I wish you success in all the projects that you lead.